I'm Chris Harrop. I'm from the Cooperative Institute for Research in Environmental Sciences at the University of Colorado in Boulder, working at NOAA, along with my colleague Noreen Barwani. And I'm going to talk to you a little bit about our work towards building numerical weather prediction workflows. First, a quick shout out to our collaborators at Parallel Works and the Parsl and Globus teams. We couldn't do this without their support. It's been absolutely critical. And the NOAA Software Engineering for Novel Architectures program that funded this work. So the problem that we're trying to tackle here is really we're trying to address the two challenges. The first is the problem of scale of the problems that we're trying to solve. Really large simulations. Some users have a hard time finding all the resources they need in one place. And the other challenge is the diversity of the resources and applications that are required to do the work. So we have diversity of the platforms and the applications themselves needing different types of resources and data. And what this leads to is a need for federated workflows. And our vision is a user being able to build a workflow on a laptop or on an on-prem system or basically anywhere with a federated identity, and then farm out the entire workflow to wherever it needs to go, whether it's solving the capacity problem or solving the problem of diversity. And so what we have is we are actually combining both Parsl and Globus Compute together. So we're using these together inside of a single workflow where we have local tasks taking advantage of Parsl on the local pilot jobs and pools, and then also using Globus Compute endpoints to submit various pieces of the workflow out to different places, and then of course joining everything back together and running the workflow. All right. So I wanted to mention a couple of really important things that was really critical for this work. And that was the collaboration that we had, which sort of, I don't know how much influence that we had, but getting the direct MPI support into Parsl and Globus Compute was absolutely critical. Our workflows are a mixture of different sizes of jobs and different geometries, but we have a very important part of that is the large jobs that run on many, many different nodes with MPI. So the system that we're building is called Chiltepin. It's basically a Python library that we're using to sort of provision the endpoints, provision the pool of resources, manage configuration of all of that stuff, and wrap these things called UW tools, which is another project that we're coordinating with that provides generic drivers for all of the numerical weather prediction components that we're going to run. UW tools handles a lot of configuration options for modeling parameters and generating the configurations and doing the actual execution and launch. So this is an example of a workflow for the model prediction across scales model developed at NCAR. You see the colors here are showing different types of resources that are required by this workflow. Whoops, sorry about that. The dark green at the bottom, those are our MPI jobs. The all yellow boxes, those are jobs that require internet access, and so they have to run on special resources. And then some of the jobs have a gradient from yellow to blue, meaning that they actually do both. And so what we're doing there is we're using join apps to build the pieces together so that we can combine and make the interface simpler for users to just run a single task, but actually it's really a bunch of things. And this is a simple example where we're installing the software. We need a service partition for cloning the app from the internet, and then we want to build it on a compute partition so we don't interfere with other work that's going on. The workflow you'll notice that there's a little L-shaped dashed line there. The work that's inside of that is the work that you do to produce the forecasts. Work outside of that is done one time to set up all of the various codes that need to be run. So installing the code, building the code, and so on. Once that's done, then the part inside the L gets executed however many times you want to run a forecast over and over again. So a little bit along the lines of what Sander presented earlier, we are also trying to work on finding ways to present this interface to users who do not have very much programming experience or knowledge of Python. So we're toying around with different approaches, building sort of like a domain-specific language of sorts. We haven't settled on anything in particular yet, but this is just to give you kind of a rough idea. What we're doing essentially is creating classes for each of the sort of broad pieces of the workflow, of the components, and then the usually roughly corresponding to the actual codes, and then providing methods inside of that that actually return the futures from that are created by the apps. So we build the Parsl apps inside of there, and so the user just has to write the code in terms that make sense to the domain experts. One thing that I wanted to highlight too is that testing this stuff can actually be quite challenging in a CI environment because for the testing that we do, we actually need a functioning cluster in order for the testing to work. And as you know, GitHub Actions doesn't have a functioning cluster. So what we did was we built a containerized Slurm cluster using Docker Compose. This is built with 3 different containers, one for the Slurm front end, one for the Slurm controller, and one for the compute nodes. And then we can instantiate as many compute nodes as we want, and Docker Compose manages all of this together, and we can actually just treat it as a fully functional cluster. And there's a shared volume, which has our software stack that we need for running all of our stuff on, that we can build all of our models against and do all of our testing. This has saved us a lot of work because building CIs that actually penetrate into the firewalls and all this stuff onto our on-prem HPCs is quite difficult. And looking forward to the future, we're going to move beyond just running the numerical weather prediction workflows and start working with the team that's doing our AI work. So we're getting started mapping out how we can use federated workflows to deal with the problems of running the physical model and gathering all of the data, and then basically massaging all of that data to produce the inputs that's needed for the training, and then doing the training on separate resources, and then using the resulting models to drive either a hybrid model or a fully data-driven forecast model. The green boxes and yellow boxes sort of represent potential physical sites where these different pieces of the workflow might actually run.